Okay, we're good. Here we go.
Don't worry, we got it back.
I'm crack-a-lacking.
I see a mobile device right here.
Yeah, please no mobile devices.
Adios, but no. Dude, I get crumbled tomorrow.
Okay. When you guys are doing a net ionic equation for a weak acid and a strong base, what is going to stay together?
Weak acid and a what?
That's going to stay together, right?
Yes.
How do we remember our strong acids?
So I brought the new
So I brought no clean clothes. So I know what my net ionic equation is going to be, right? It's going to be HCOOH plus, what's not going to be left? OH minus is going to give me HCOO minus plus water. So you can kind of think quickly through that. Think what's not going to break up, what is going to break up. If you mix 1 molar weak acid with 1 molar of strong acid, weak acid with a strong base, it's going to be slightly basic. Why? Because the base wins, right? Yes? Because the base wins. The base wins. Why does it win? Because they're both equal molar, right?
Yeah.
But the base wins because why?
Because it's strong.
More dissociation. More dissociates. Weak base, strong acid. Okay, on this one, my strong acid is what? Hydrochloric acid. So that means that this is going to break up. So if I was going to write my net ionic equation on this, it's going to be CH3NH2 plus H plus gives me CH3NH3 plus what? Technically water, right? Technically water is going to be there because it says AQ. Yes, it says AQ. You mix 0.31 moles of this with 0.57 moles of HCl. You then add water until a solution is produced. What's the pH of the remaining solution? Let's write this thing really quick. Reaction, I have CH3NH2. I have, this is going with HCl, so I have H plus, and that's going to yield my CH3NH3 plus. Do I care about the water on the other side? No. So I have 0.31 moles. So guess what I'm going to start out with? 0.31 moles. Make a note. H plus, I have 0.57 moles. Am I going to start out with any of my product? No. Change. I'm going to add it right here. I'm going to keep going on this page. What's my change going to be? What? It's minus what? It's minus 0.31 moles. Why is it minus 0.31 moles? It's a 1-to-1 ratio, right? That means this must be my what? Limiting reactant. So whatever's less is what you're going to subtract. So this one has to be plus 0.31 moles. So this is 0. This is 0.26. And this is 0.31 moles. I don't care about this because I want the pH. So this is in how much? 1 liter, right? So 0.26, now I'm going to flip the page. 0.26 divided by 1 liter is 0.26 molar, but I need the pH of that, so I'm going to take the negative log of 0.26. Negative log of 0.26. Yes? It told us. And I got 0.58 for my pH. Okay. So sorry. Yeah, it's weird because this does not do well long ways. Okay. This document camera is more of a hot dog style than hamburger, right?
Yeah. Right.
Because this is hamburger.
No. It's hamburger. What?
Huh?
Hot dog. Hot dog is long way.
This.
I feel like it needs to be up there.
I feel like we used to see. So why do you order?
Oh yeah, that's not gonna work.
No, that's hamburger.
I would have to write
I
up.
feel like it needs to be up
No,
more.
just like, does it have to be in that
Like,
position?
it like moves.
I don't know.
No, like, can't you move it to the other side of the
I could if this had any more give. I have to rearrange my desk next year. I'll make it better next year. At this point, we're just gonna deal with it. Yeah.
Do you request 2 desks? Or
I've just always had to. Yeah.
You just said so much more.
It just gives you more of a presence in the front of the room. So, yeah, aura per se. Anybody have the Aura ring?
My
I
dad does.
asked for it.
What's an aura ring?
It's a ring that tells you like all of your health stats.
yeah.
It's basically a stalker.
The thing is, it tells you about your sleep, and I don't know if I want to know how well I sleep.
Because then I would like have a
For
bad day.
my
even
dad,
if
my
I
dad,
did.
it told my dad how stressed he was, and it made him more stressed.
Yeah,
Like.
I don't need that. I slept great last night. That's all I know. So,
You just tell me sleep.
yeah. Yeah, I slept good. Shut up. That's me talking to my Aura ring. No, I'd be nice.
It's gonna give you aura.
This is the problem. You need to be nice to your AI, people, okay?
Dude, I was correct. No,
I
no,
was
it started.
Andy was setting his death threats last night.
Listen, do you know how much money it costs extra for AI to respond when you say please or thank you and it has to say you're welcome per year? It's like $1 billion for ChatGPT to say you're welcome. Because extra computing.
But I'm thanking my AI.
Well, I'm just saying.
I've never.
Because every response it gives takes energy, right? Takes more electricity.
What if I just say thank you in the first response, like I don't want an extra one? Like I'm like, can you do this thank you?
Thanks are just
I don't know.
I guess.
Well, it's still typing out more or less.
Yeah.
All right, let me get started. So my plan was, I took the Thou Shalt Not Forget questions and answers.
Oh,
I
that reminds
scanned
me.
them all in,
Yes.
and then I was gonna put it in a Quizlet, right? So I was like, okay, it's gonna take me forever to combine all the questions and answers. I need
Yes.
to make a list of work. So
I'm listening.
I go to ChatGPT. I barely used ChatGPT before, and I would literally took me probably 2 hours to even get it to sequentially order the list of questions.
Okay.
I was arguing with this thing for 2 hours. And at one point I was just like, dude. And it was like, I'm so sorry, I'll try again. And I just, I was literally, it was just dumb. Like, it just doesn't.
Poor ChatGPT. Poor Chad.
I was like, just back it
I
up.
wonder if we could like bankrupt it if we all just like.
Oh, I'm sure you could.
Well, that's why I haven't done it.
They do.
All right, 1 second. I had seen something on my AP Chem Facebook group where somebody had made a Thou Shalt Not Forget Kahoot with all the questions.
Can I get a password in my locker? Is it actually
Yes.
called Locker Laundry?
It is called that.
Yeah.
I wasn't here like when this all went down.
Really, other than
Do you not have the paper with all the answers?
I gave that to you. Yes, I did.
I think he gave it to you.
He
So
did
you
pick up
did it?
extra.
Yes, I did.
Well, that one time you claimed you gave me like a review packet or something.
Okay, well, I gave you this.
Wait, if you didn't give me the review packet, then you probably had to give me
I did because I don't have it. Let's see if I have it.
the quad. He's gonna put it. Why are you giving us the answer?
What?
Why are you giving us the
Because that's the whole point. You have the answers, so you memorize them, and you do well on the quiz. You get a 60 out of 60, and if you know that, it's going to really help you on the
That's
AP
why I've
test.
just been like taking it over and over again.
No, you should have all the answers. Haley, I'm so sorry.
It's Danny's fault.
I think I gave it. I don't have it.
Yeah, I haven't gotten over 75%. I've taken it 4 times.
No, Haley, I definitely.
And I haven't looked at the questions yet.
Yeah, that would help.
It's
Well, I got
gotten
a
better
60
every
from
time.
just
Good.
doing it.
That's not bad for just doing it.
Like my first.
Yes.
Why is it the science teachers that are in charge of detentions?
Always been like, it's just always been that way. We have a monopoly.
Neither do I.
It's nice for like making up labs and stuff and making up tests. Okay, hold on, guys. I am posting a Thou Shalt Not Forget Kahoot with all 100 questions.
Play that.
Well, this is half of them. It'll help you with some of them. It's some.
Laser light show.
15 minutes.
Every period, pretty much.
Wait, you have
Hello.
Jared always has one.
6?
Wait, is this the stuff that's in the LGIR, or is this?
No, this is when the lab's all dark.
Remember when we had to set up for
I can't sixth period. We have 3 classes in there. It's gonna be mayhem.
We'll sit on the,
There's gonna be like 80 people in there.
we're all in and like
Oh,
we're next to
crap.
There'll be so many people. All right. Here we go. Weak acid, weak base. In the bottom row, label each as an acid base, conjugate acid, conjugate base. HCN is a acid. Therefore, CO3 2 minus must be a base. So what over here? HCO3 has to be my conjugate acid because it starts with H. So this is my conjugate base. In the bottom row, we did that. Study the Ka, Ke, Kb values. Will this reaction favor products or the reactants? Where's the Ka, Kb? Did it give it to us?
It's what's listed below. See the word.
Oh, yeah. Okay. So which way is this going to favor? Products or the reactants? Well, what's stronger? This will favor what? Products. Will favor the products. Why? The reactants do what? Will break up. Products won't. Because we know the higher the Ka, the more it will break up. So Haley, do you have the answers now or not? Whoa, we're moving.
Billy, look
Just
in
to
your
figure out what
board.
he's saying.
I
Okay.
looked through my board to make sure I
Remind me at the end of the period. I can give it to you. Okay. The equilibrium constant for the above, it might be an AP Classroom too. I don't know. The equilibrium constant for the one above is greater than or less than 1. Greater than. Because my what is favored? Product is favored. And remember, K is products, right? Products over reactants. So that means it has to be greater than 1 to favor it. The above reaction is allowed to reach equilibrium. Will the pH be above, below, or equal to 7? Below. Why? It's basic. So the Kb for Cn minus is higher. Because my Kb for Cn minus, what's that?
Is it above basic? Yeah, I thought above was basic.
Below basic Kb.
Below is acidic. Yeah.
Did I flip it? Above.
So I was right.
Should be above, yes. pH will be above because it's basic because the Kb is higher for Cn minus. Good catch. Next page. Guys, I put on a Keen Science night last night at Keen. It was pretty awesome.
What did you do?
Everything. Blew some stuff up, flame test, burned some magnesium. You know all the flashy stuff. No, but we did do the glow stick in the test tube. Did I do that when you guys were freshmen? Okay. And we heated it too fast, so the test tube cracked. So it was like a glowing waterfall. It was actually legit cool.
That's actually pretty.
It was really cool.
You make like elephant toothpaste. I think that's
Yeah. It's I don't have the right stuff yet. I can get it to go really good, but I can't get it to like shoot up and hit the ceiling yet. So I'm working on it.
In that one movie, Yes Day. Have you seen that?
I have not seen
Where
that.
the kid like
Like the
the
parents.
kid makes so much that the whole house is.
Like Mark Rober.
Yeah.
Yeah.
I've heard that.
Yes.
So, is that that 7.1 or something like that? Like, is that set in notes? And then thou shalt not forget like the last 2 things that are going in Mars book?
So you have this
What?
7, chapter 7. You have thou shalt not forget. Yeah. And then you should get 100% on your final.
Right.
Remember, your final is 10% of your grade. So after the AP test, I will print all the labs. I'll give you a binder clip. You'll binder everything together and you get 100% on your final. Unless you've lost them. And you have to write a 2-page paper
I have more.
from the ones that you've lost. So,
I mean, everything's in that folder.
It's over for
Danny.
Danny.
Is it over for Danny?
No, I have one more.
I have a lot of trust.
All right.
I should have one.
What is the purpose of an acid-base titration? What are you doing? First of all, you're neutralizing, right? Yes. You are neutralizing an unknown concentration, right? With a standardized acid or base. So then you can figure out the moles of one, figure out the moles of the other. What's the purpose of an indicator in a titration? An indicator changes color based off of what? Yes. Changes color based off of pH. And when should it change? If you have picked a good indicator. It should change at what? Equivalence point. It should change at the equivalence point. Data taken during the titration can be used to create a graph called titration curves. Using your knowledge of titration curves, circle the correct phrase to complete the following. A strong acid will react with a weak base to produce a curve with the equivalence point less than, greater than, or equal to. Less than. A strong acid will react with a strong base less than, greater than, or equal to. Equal. Weak acid will react with a strong base. Greater than. Way to use process of elimination.
What are we gonna do with fun lab?
That's all we're doing after the AP test. Yeah.
And pickle.
Like, to
Oh,
what extent?
yes. After the AP test, we're just having fun.
So I
Speaking
should
of after the
like
AP
If
test,
I don't want to play pickleball, can I just down?
Yeah.
you just hang out.
Just, you know.
Next week,
Heck yeah.
we are tie-dyeing either Wednesday, Thursday, or Friday.
So do we need shirts?
So you'll need a 100% cotton t-shirt or whatever you want to bring in, socks, anything you want to tie-dye. Yeah, people have done socks.
I just saw.
So
That was so mad.
You can bring in more than one item. What?
Like any of the
Yes, we'll probably just pick whatever day you're not taking an AP test. So Wednesday, Thursday, or Friday. Yeah. So we'll go in. You need a 100% cotton t-shirt, pre-washed and rinsed in dish soap. Rinse it back out. It can be wet in a gallon Ziploc bag.
And it was like.
Cool? So
So should I bring my
How rough, like when yours out?
we'll need our pickleball materials probably starting the next week. Yes. We also have to do shrinky dinks. We got to do. Yeah, we've got a lot of labs we still have to do.
Draw them, like make them.
Oh yeah.
Oh my gosh, stop.
Yeah.
I'm gonna cry. I'm so excited.
Yeah. All right, flip the page.
Oh yeah, Danny won't be here.
What? Where will he be?
So how many graduating tests do we have?
Danny's graduating.
Well, seniors have like
AP
3.
test is on Tuesday.
Juniors have like no.
Yes.
Seniors have like 2. Juniors have like 3.
2 weeks.
Something like
Yeah.
that.
Play football.
Oh, I guess 2 weeks from today.
We have,
Yeah.
we have like 11 days.
Yeah. Okay. Half equivalence point. At the half equivalence point, my pH equals what? In a buffer. pKa. Concentration of HA should equal the concentration of A minus. It's a buffer. And blank of the analyte has reacted with the titrant. Half, yeah. So what's the halfway point? So, student followed, observed the following titration curves. One is from HNO3, one is H2SO4, and one is KOH. Which is which? Well, first of all, which one is H2SO4? No.
Third.
The third one. Because H2SO4 has to give up two protons, right? So there's 2 equivalence points. So I have EP1, first proton, EP2. Okay? Which one is the titration of HNO3? First one. Why? Because my pH starts what? My pH starts low. Here's my equivalence point, which means this other one has to be KOH. Because my pH starts high. pH starts high. Here's my equivalence point. Here's our example, a 50 milliliter sample of HF, unknown concentration titrated 2.1 molar KOH. The graph shows data taken during the titration. What is the concentration of the HF sample? How would I figure this out?
Like the starting, like 10.
So I have 50 milliliters, right? Yes? Does this cut off? Does it go on to the next page? Because I feel like I need more information.
Just okay.
Gives you the Ka. Here, we need to have more information. You can't solve this unless you have this. So you need to have 5 milliliters, 10 milliliters, 15 milliliters. Now you can actually answer the question. Because 10 milliliters is my what? That's my equivalence point, right? So 10 milliliters is how many liters? 0.01 liters. And I know that for every 1 liter of KOH, I have 2.1 moles. And that will equal, I got 0.0231 moles of KOH divided by how much did I add in? I used how much? How much did I start with? Divided by 50, which is 0.05 liters. So that gives me 0.462 molar. This is exactly what we did in our titration. Where would the 50 milliliters have come from? It would have come from our burette, right? Yes?
Yeah.
That's how you get your exactly 50 milliliters. And this only works because this is a 1-to-1 ratio, right? If it wasn't 1-to-1, you would have had to do a mole ratio in between there, Stoich step. Cool? Okay. Lucy, what is that? That looks really cool.
I'm thinking about cutting it open.
What? You're dreaming of cutting it open?
Yeah, that's what I was thinking. I have my other one in my locker. I have 2 of the exact same ones here. You can continue.
Well, this is like experiment. Do it on the.
Oh my god,
No, we gotta keep going. We gotta keep going. What's the Ka? Yeah, thank you. Of this solution, I know for Ka that pH should equal pKa at the midpoint, right? Yes?
Even Heller wants to.
At the halfway point. So at the halfway point, if I go back, it's essentially 5.5 milliliters. And I can look over there and it is a pH of 4.5, which is my pH. So I'm going to take 10 to the negative 4.5. And I get 3.16 times 10 to the negative 5th. Is it wet? Oh, it's shaving cream almost.
Oh.
Just put a Band-Aid on it.
Wait, squeeze it out.
Nice,
Yes, I know, I'm just putting on a paper towel.
Do you need a Band-Aid? No, seal it back up.
It's like Dr. Pimple Popper.
Oh, that's so gross.
This is my extra.
Because we were curious.
Smell it.
Back up.
It's shaving cream.
Let's put the chemicals in.
Or is it toothpaste?
The chemical closet in.
A student conducts an acid-base titration. They find 35 milliliters of this is required to titrate 0.265 molar to the endpoint. What's the initial volume of the acid? How many moles? Guys, these are all the same. These are all essentially the same. Let's just set it up. So let's write our equation. So I'd have CH3NH2 plus HCl. That would give me CH3NH3 plus what? What's my other product going to be? Cl minus, right? Because acids donate, yes? So that's why this went from NH2 to NH3. So my rice would be CH3NH2, H plus, CH3NH3 plus, and Cl minus. I will post the answer to this later if you want to work this out on your own, but we've done a ton of these. Let's keep going. Okay, 8.6. So we are at molecular structure. Molecular structure of these. So blank defines a strong base as a proton. So Bronsted, Lowry, Arrhenius, or Lewis?
Lewis.
You're just yelling out random answers.
Bronson.
Bronsted, Lowry. Bronsted-Lowry defines a strong base as a proton acceptor. Blank defines a strong base as a hydroxide ion donor. Which one is that going to be? Hydroxide is Arrhenius. Arrhenious. Blank defines strong base as an electron pair donor. Lewis. Because I always think of Lewis dot structures. Know what a Lewis dot show? Electrons. Electrons. Acidity increases as the bond strength, bond polarity, conjugate base. So, as the bond acidity increases or decreases, as the bond strength does what? So you gotta start thinking about this. What's gonna make it more acidic? A lesser or greater bond strength? Less. Why? It's easier to give up the H plus, yes. Easier to give up the H plus. So which is the stronger acid? These are both strong acids, right? Is there any way to know without the Ka? No, it's HBr. Okay. Increase or decrease with the bond polarity or electronegativity? For the bond polarity, it's going to increase. Why is that? As the polarity, this is a little bit of trends, increases, more electrons are pulled from H. So, it's easier to let go. Let it go. Guys, did I tell you about my innocent conversation with my wife the other day? So, my mother-in-law, well, my wife's parents, after we got back from Disney, they're like, man, we would have went to Disney with you. We would have loved that. Like, oh, we should go back to Disney sometime. So then we were at the park where you can walk. There's a lot of those. No.
The one by the tennis place?
No. Spangler Park.
Worcester Memorial.
Worcester Memorial, thank you.
Oh, yeah, that was the
So we're walking and we're just chatting, like, man, it would be cool to go to Disney with your parents. And then 1 hour later, we had a Disney trip booked. So,
No way.
yeah.
You what?
We're going to split the room with her parents. We're going back in February. We're doing it again.
It was almost 3 times in 1 year.
It was 3 times in 13 months. But now this is going to be like 11 months between trips, which is more appropriate.
Obviously.
So we're going to Disney again.
I might see you here in February.
This will be our 4th time now.
How many times have you gone in your life?
5. I also went once when my wife was pregnant, so 6, I guess. But up until I was like 39, I hadn't gone since like high school. So. But like, our kids are young. We're just trying to YOLO a little bit. Because like, you know, I've got some extra.
YOLO when your kids are 18.
I know, we'll YOLO then too, but like, what if I'm not alive when they're 18? Okay, that's really morbid. But like, I don't have any like major things wrong.
Time they're gonna be this age.
Yeah, yeah. This is their Disney era. That was really morbid. I'm planning on being alive when you guys are 18. If you ever look on this up, first of all, if you guys watch this on YouTube, you find this on YouTube someday, I love you all so much. I would miss you, but hopefully I'm alive when you're 18. No. We don't let them.
Yeah, that's a good thing.
I'm just saying, YouTube is 3 clicks away from weirdness, so.
Yeah.
Pop ads, don't click on them. Don't click on pop ads.
As my conjugate base stability increases, Y, a more stable conjugate base is more likely to let go of, this is a more stable conjugate base is more likely to let go of its H+. Oh, we forgot to circle here. Which is the stronger acid, HOCl or HOI? You'd have to draw these. It's HOCl. All right? And then over here, which is the stronger acid? It's this one. It's longer. Yep, you got it. Flip it. Are we gonna finish this? We still have 8 more? We better move fast. A strong base will have a weak or strong conjugate acid. We know that's the opposite, right? So it's gonna be weak. Why? We know why. Okay, weak bases have a pH range of 7 to 10 and small Ks. Many weak bases contain the element nitrogen because it has a lone pair of electrons that's able to bond with H. Here's a reaction showing the dissociation of a carboxylic acid, including resonance structures. So label the acid base and conjugate acid, conjugate base. So over here, which one of these is my acid? Which one is my acid? This is my acid, right? Which means water is my base. So H3O plus is my conjugate acid, and this is my conjugate base. What am I showing here between these arrows? Resonance, yes. Explain how resonance structures in the RCOH increases the acidity of carboxylic acid. We still have half an hour left, right? Okay. How does it increase the acidity? Well, the electrons can pull away. The electrons can pull away from the OH group. Pull away from the OH group towards oxygen, which would then have more electrons. So this will increase polarity. That will increase polarity. I think we're going to finish this, guys. And the OH bond, this is a lot to write, making it easier to pull another H+. How does the resonance structures of RCOO increase the acidity of carboxylic acid? Hey, what's up? It worked.
Is it good?
Yeah, I checked it. Thank you so much. Yep. Explain how the resonance structures of RCOO increases the... Mr. Ott.
Mr. Ott?
Yeah, Ben Ott.
He's Superman.
He is. He wears Superman every Friday. Yeah.
He wears Captain America too, right?
Captain America and Superman, yeah. He's just technology person.
Oh.
Yeah. He installed like a major update on my board, so I have like a board within a board now. It's crazy. I can't show you right now, but it's wild.
So like tomorrow.
So if I have RC, not tomorrow, maybe like after Tuesday. Yeah.
Good idea.
Increases the acidity of carboxylic acid. On this one, electrons can delocalize. They can delocalize between both oxygens. Yes. Between both oxygens. So it's technically more stable. Therefore, I love my ... RCOO is more likely to donate an H. More likely to donate an H. Consider the following acids in order of increasing strength. Circle the acid with the most stable conjugate base. Which one's it going to be? The most acidic, right? The strongest original one has the most stable, or the weakest. Correct. Stable means weak. It does not want to give up. It's H. It's going to be HF. Flip the page. Oh, we're going to do this. I'm feeling locked. Also, that food filled me up more than it should have. I don't know why. It was the rice. It was the rice. Explain why it's more stable. Wait, what? Did we miss a question? Oh, well, also, F is the what? The most electronegative, right? The most electronegative element. Here we go. Complete the chart. pH versus pKa. So, first one. Ka equals 1 at equilibrium. If this is true, my pH must equal pKa, which means my HA must equal my A minus. We're talking about these right now. Talking about these. Which means this is going to be neutral. If my pH is greater than pKa, my Ka is going to be less than 1. Good. Which means my HA is going to be less than my conjugate, and that's basic. And if my pH is less than pKa, my Ka is greater than 1. On this one, my HA is going to be greater than my conjugate, so this is going to be acidic. You're studying a buffer solution. You know that pKa of a solution is 4.2. You measure this pH is 8.5. What do you know about the relative concentrations of the acid and conjugate base in the solution? I know that my pH is what compared to my pKa? Greater than my pKa. Therefore, my concentration of my base is what compared to my concentration of acid? Greater than my concentration of my acid. So, to the right, the diagram showing protonated versus deprotonated indicator molecule. You're using bromoethanol blue, which is a yellow and 6 and blue in a pH above, this should say above 7.5. The cutoff, above 7.5. Color or label the appropriate circle yellow and blue. Which one would be yellow? Which one would be blue? What?
Do we do something similar to this?
This is just talking about indicators. We talked about indicators. We didn't like do something this specific. I don't think you would. This could be like a multiple choice question, maybe. Well, not coloring it. It'd be like just choose. The right is blue. Why? It's a base, right? Yes. And we said it's blue in a pH above 7. H is going to be yellow. Because H is technically, this is the negative, this does not have the negative. That's it. So don't overthink that. Moving on. My hand is starting to hurt. How are your hands doing? Danny, how you doing? What? If H plus ions are added, the solution becomes more acidic. The indicator reaction above will shift to the left, and the solution will become more yellow as more indicator molecules become protonated. If there are fewer H plus ions, the solution becomes more basic. The indicator will shift to the right, and the solution will become more blue. This is a great example of Le Chatelier. I'm sad we didn't get to talk about that. You guys did that on your own, but you guys know Le Chat. Okay. Explain why the pH of a buffer system remains relatively stable. What can a buffer do? A buffer can eat. Specifically, what can it eat? Both. Acid and base from its conjugate conjugate base or conjugate acid. Weak acid conjugate base or weak base conjugate acid. There's going to be a conjugate pair there. Here's an aqueous buffer solution. The water molecules are left out for clarity, just like we did. Study the diagram of the buffer solution. Draw the symbol that represents the conjugate base. Which one is it? Is the single circle or is it the double circles? The single circle. Because I know HA has to be two things, right? So this is going to be the single colored in and the lone one. Change this diagram to what will happen when this H plus ion is added to the A minus. So here's my H plus. It's going to be added here. What am I going to draw? I'm just going to draw one of those, right? Yeah. Complete the equation. H plus A minus. I know, mind-blowing. H plus A minus gives me? Yes. What happened? Accepted a proton, right? Accepted proton, or you could say I made ha. Made ha. Change this diagram to what will happen when this base is added. So now I'm adding in a base. So what am I going to draw on this one?
Isn't the little circle connects and then the big circle like is on its own?
Would it break up?
What am I gonna make if I added a base?
Oh, water.
Water. I'm gonna make a water molecule. I'm gonna make a water molecule. So OH plus HA, right, is gonna give me H2O plus A minus. Right. You got it. Now there's one that's just floating around. So what happened here? OH plus took my H plus from HA and made H2O. Those are good little particle diagrams. I like that. Oh, here we go. Look at the next page. Henderson-Hasselbalch. But first, let's do this one. 8.4 says when a weak acid and a strong base are mixed, if the weak acid is in excess, the buffer solution is formed. Why is this the case? This means what has all been used up? This means all what was used up? Strong base, you're right, Ella, is used up. So this leaves only the conjugate base, right? Yes? Yeah. Plus the weak acid, which is literally the definition of a buffer. So down here, it's useful to consider, use the Henderson-Hasselbalch equation to prove that pH equals pKa when the concentration of an acid base is equal. We know that pH equals pKa plus log of the concentration of the conjugate over the concentration of the acid. So if this is 1 and 1, or 2 and 2, or 3 and 3, right? What is the log of 1? 0. Log of 1 equals 0, which cancels out that whole thing, which means if this is gone, what is equal to each other? pH equals pKa. Answer the following questions for buffer solutions of nitrous acid and sodium nitrate. Here's my Ka. So what is my pKa? So what am I going to do for this letter A? This is a weak acid. So you can't take a direct negative log. Henderson-Hasselbalch. So pH equals, let's see, do we have a pH? What is that sound?
That was me.
Oh, I thought that was like coming from somewhere.
That was me. Typing. I don't know how you do
Zippy, do it.
What am I doing?
Do it. No, that was really slow. That wasn't as good as I was not doing it. You're out of practice.
It's not the motor's fault. Well, when we were in the wind, it really just, it was so loud.
Can I hear it?
Do it.
That's actually kind of good.
It was fun making me speak out a little bit.
The wind was making me speak.
Oh yeah, the wind was making me speak.
I wouldn't be right.
You kind of get enough oxygen then.
Danny and Haley were big.
I just feel like we're missing information on this.
How are you gonna do it? Do we have to ice it?
That's maybe every day.
To get the concentration? And then he plays it.
Doesn't pH equal pKa because it's 1 to 1?
Yeah, you're like,
Where do we don't have an equation
you
though.
don't have to do it.
Heller's gonna start getting out of consider.
I think you would almost have to be given the pKa.
This says a buffer solution of nitrous acid and sodium.
Oh, okay. So you would have to look up these numbers. They're assuming that we're looking up these numbers, which we're not going to do. So let's say that our nitrous acid is, well, let's just say 3.14. All right. And my nitrous acid is, let's say that this is 0.23 molar, and this is 0.023 molar to make our numbers easy. See what I'm doing here? Everybody see it? Mm-hmm. So pH equals 3.14 plus log of 0.23 over the log of 0.023. right? So this divided by this is what? 10. Log of 10 is 1. So 3.14 plus 1 equals 4.14.
But we didn't have to solve
Well, you would have needed more information, which there's a separate packet that goes with this that has it, but it's fine. Okay. That next one, you guys know how to do that. Let's go. Let's keep moving because I really want to get through all this. C. Let's do C. A mixture of HNO2 and NaO2 has a pH of 2.15. What's the A minus to HA ratio? You figure that out. Henderson-Hasselbalch. pH equals pKa plus log of A minus over HA. So I know that, here's my pH, 2.15 equals, from the last one, 3.14 plus log of X, right? So I'm going to subtract. So this means that negative 0.99 equals log of X. So you're going to have to do some anti-logs, and you ended up with X equaling 0.102, which is equal to my concentration of A minus over HA. These are all just rearranging. Whenever you have Henderson-Hasselbalch, it's going to be plug and chug.
What if I don't remember? Did we get that?
I believe that's on the equation sheet.
it. Should.
I believe that is on the equation sheet.
You didn't learn after sheet and you're really smart and you know how to do math. Do you think someone could like
I think someone could get a 3.
just based on how?
By reading graphs,
That's what I'm saying. Like so that
by having a good get, by if you like ace the multiple choice, and we're a really good guesser,
if you're good at guessing and
because remember it's 50-50, right? So if you got, it's 50% multiple choice, 50% FRQs. So if you got a 90 on the multiple choice, and then you got a 30 on the FRQs, that's 120 divided by 2, that's 60. That'd be a 3.
Okay,
So,
So someone could just walk in, not learn
That's
the
also
class.
90 on the multiple choice.
right. Just saying.
Like someone could walk in not knowing the class and use the equation sheet and still do well.
Did they take like basic chemistry, like ever?
Yeah, like after,
Yeah, sure, they
after
took
last
basic.
year, they were like, I'm just gonna take a test.
I think someone very intelligent could get a 3.
So since we
Like,
have
I'm
to-
wondering how much the equation sheet is. That's kind of
The equation sheet's nice when you're stuck. So if like they give you something, look at what they give you, go back to your equation sheet, be like, oh, this is entropy, or oh, this is going to be the ideal gas law, or oh, this is going to be your KW, or you're talking about like Planck's constant, 6.626. Yeah. Okay. How many milliliters of this must be added to 0.150 molar acetic acid to make this? Guys, this is really specific, but let's just, how much more do we have?
Let's just.
I feel like we've done a bunch on this same one. So we can check those answers later. Let's go to the picture. Picture's important. Consider the buffer depicted at the right. The pKa of the buffer is 7.4. The pH of the buffer is greater than, equal to, or less than 7.4. So I have HA, which is equal to this, right? And I have A minus, which is equal to this. Count. It's 7 to 4. So I know that it's going to be the log of 4 over 7, right? Technically. So what is log of 4 over 7? I don't even know what that is. It's negative, right? So therefore, my pH is going how? pH is going down.
also you can just think like, what's gonna be more stable.
You could think about it like that too, but if they ask for the math to back it up, you could show it with that. Yep. Buffering capacity is defined, I like your perch, as the quantity of strong acid or strong base that must be added to 1 liter of a solution to change it by 1 pH unit. So I have HNO2, Do I really care about the H? No. I'm adding that to H plus, and I'm getting HNO2 plus H2O. So what do they give me? They say I have 0.5 molar to begin. I have 0.035 molar of H plus. For my HNO2 on the other side, well, H2O is not part of this, right? So on the other side, I've got, let's see, 0.5 molar as well. It's the same. So my change is minus 0.035 molar, minus 0.035 molar, because it's the same, plus 0.035 molar. So I get 0.465 molar, 0.535. Now, it's asking me for the pH. So I know that pH equals pKa plus log of 0.465. There's my minus over my 0.535. There's my HA. What was my pKa? It's right here. I'm sorry, what was my pH? Well, I know that my pH is going to equal my pKa. How do I know that? Because these are equal molar, right? If it's 0.5 and 0.5, I know that I'm at the halfway point. So add that up, and I get 3.19. I get 3.19. Moving on. By the way, if you do this next one, your answer is, I believe it's 2.5. Or check, I'll post this later. Consider your results for the previous two questions. Buffer solution A has a higher or lower. So buffer A would be higher. It's just more moles. You now add 0.035 moles of KOH to both. Which buffer will have the least change in pH? Buffer A. Why? It has a higher capacity. Has a higher capacity. Whew. This is it. Here's buffer 1, here's buffer 2. Between buffer 1 and buffer 2, which has the highest capacity for absorbing 0.2 milliliters of 0.03 moles HNO3? Yes. How do you know? More moles. Yes. Buffer 3, which one has a higher capacity for absorbing 0.2 milliliters of 0.03 HNO3? 3. Why? First of all, what's going to be eating up the HNO3? The negative. So on this one, I've got to compare the negative. Which one has more moles? CH3, COO minus. That is all the units reviewed. What? Where? Oh. All right. 0.003 moles of NaOH. Which one? 2. Because NaOH is a base. And then 0.03 moles of NaOH. 3 or 4? 4. Which buffer 1 through 4 has the highest pH?
2.
No.
3.
Buffer 3. Buffer 3. Which one has the lowest pH? Buffer 4. Buffer 4. Those would be great multiple choice questions. Tonight, 7:15, we will feast